Good afternoon, everyone. It gives me immense pleasure to welcome you all to this insightful webinar on innovative solutions for water conservation. I am Dr. Kritika Shetty, and as the coordinator for SDG 6 at Nitte University, I am delighted to see such enthusiastic participation from the faculty members who share a common commitment to sustainable development. Water conservation is a critical global priority, especially in the face of challenges like the depletion of groundwater, drying of wells, and the shrinking of lakes and water bodies. These issues are not just global concerns, but also pressing local challenges that we must urgently address. Today's session aims to provide us with innovative approaches and practical solutions for tackling these problems. We are honored to have here with us Professor Dr. Suma Ballal, Deputy Registrar Nitte DU and Chief Coordinator SDG Cell. I now request ma'am to deliver the welcome address.
Thank you, Dr. Kritika. Am I audible?
Yes, ma'am.
Yeah. Okay, good afternoon to one and all. At the outset, I would like to extend a warm welcome to all the faculty who have joined this webinar on water conservation, and also a special welcome to all the heads of institutions. I can see Dr. Dhaneshwar Pai sir and all the heads of institutions, all the senior faculty, the professors, and all the staff who have gathered here for this webinar. As we are aware, water conservation is not only a global concern. Today, it has become a local concern. And for those of us who are staying here in Mangalore, we are aware how rationing of water was happening during the last summer. It is ironic indeed that during the rainy season, there is so much of flooding, and during the summer season, it goes really dry. So today we have with us a beautiful webinar on water conservation, and the resource person will be Dr. Bojaraja. He is Associate Professor, Department of Civil Engineering, NMA MIT Nitte. So thank you, Dr. Bojaraja, for being here with us today. I hope that this webinar is going to be useful for all of us, and we can actually learn how to do water conservation at a personal level. Over to you, Kritika.
Thank you, ma'am. Thank you. Our resource person for today's session is our very own Dr. Bojaraja B, Associate Professor in the Department of Civil Engineering at NMA MIT Nitte. Dr. Bojaraja holds a BTech from Siddhaganga Institute of Technology and both MTech and PhD degrees from NITK Surathkal. He brings with him over 7 years of teaching experience and 5 years of research experience. His work in the areas of remote sensing and GIS applications in civil engineering, particularly in hyperspectral remote sensing for vegetation, is widely recognized. He has published extensively, secured significant research funding, and has several patents to his credit, including the notable aqua hydroponic integrated with interlocking clay brick building for vegetation cultivation. He is a recipient of the Hydro 17 GM Navate Award for the best paper presented at the Hydro 2016 International Conference and has also won best paper awards at various conferences. We are truly fortunate to have you here with us today, sir.
Thank you, madam. Thank you for the nice introduction, and also for inviting me to share my views on this particular topic. Is I audible?
Yes, sir. Yes, sir. You are. You are.
Okay. Shall I share my screen, madam?
Yes, sir. Please go ahead. Yeah.
Is it visible, madam?
Yes, sir. It's visible. It's visible.
Now, in the slideshow mode, is it okay?
It's visible. It's visible, sir.
Okay, madam. So, respected faculty members and my dear colleagues, so I'm delighted to share my views on this particular topic on innovative solutions for water conservations. So I'm working in the Department of Civil Engineering as an associate professor. So the overview of my presentation goes like this. So what is water conservation, or why we need to conserve it, and what are the global water challenges? So what is the availability of water, and traditional conservation method, and we are comparing with it technology based and also community based, and what and all we can do. So these things we are about to discuss in this particular webinar, and there are already some nature based solution. Can we adopt it, or can we go with the community based approaches, or what is the future trends in water conservation? And we need to adopt some technology from nearby countries or neighbor countries, the best practices, and there will be some conclusion remarks, and followed by question and answers sessions. So here, so what is the availability of water? As we know, the population is going to rise and year to year, but the resources are limited. So that is why, so we need to go for this particular sustainable solutions which can improve the particular resource management, and also for availability and these things. Okay, madam. So the demand is continuously increasing and the resources are limited. That's why we need to explore some innovative solution. So why? That is the question. So if you see the global water availability, only the point like 75 percentage of water is available on the earth, but it is not useful for the drinking purpose. Most of the water is in the presence of the ocean. So that is, as we all know, that is salt content is rich in that. So that is why what is that we need to save this water. And among the 2.5% of the water, again it is in the form of ice caps or glaciers, so that we can't use it. And the another some percentage, that is less than 30%, is in groundwater. So always we should not conserve this groundwater like it is like a fixed deposit. So we should not consume it. Only the surface water is available 1.2%. So that is why, so this particular conservation is very crucial role. So if you ask what is the source of a water? So the source of the water is precipitation. So once the the precipitation occurs, it will be on land, it will be on water, so all those things. So some percentage will percolate through the soil and it will contribute to the groundwater recharge. And most of the water is contributing like a runoff. So runoff is increasing because of the construction activity and pavements, all those things. Because of the rigid pavements and rigidity of the surface, all the water is runoff. So that is why we are facing this floods, all those things. So now we witnessed the Kotara Choke as an example. All those because of the what is it? Infiltration is less. More runoff, it's contributing the flash floods. So here, once the water is infiltrated, then it will contribute to the groundwater zone. Again, here there are two type of groundwater zone. One is confined, and another one is unconfined. So these two we can use for a recharging, and some portion will be in the form of water bodies, lakes, and all. So again, the water will be transmitted back to the atmosphere by means of evaporation, transpiration from plants, and condensation happens. Again, there will be a form of clouds. Again, due to the sunset, again it will be in the form of precipitation. So now nowadays we can witness there is a irregularity in rainfall. That is also one of the reason we can face this water issues. For that, mainly the reason is deforestation and increased urbanization. So these things we need to address. So Then what is the traditional methods of water conservation? So here, if you see the traditional methods, the rainwater harvesting is the best practice in the ancient days. So nowadays, now in some cities it is mandate, like we need to go for rainwater harvesting. Then only the house construction license will be provided and all. So some policy is there. Then efficient irrigation. Which irrigation system is effective for both for the yield and also for the crop, and you can save the water also. And is there any reuse of water, wastewater? All those things can be practiced, and water saving practices by individual so will help us to, you know, save the water. So you can see in a different region, the names are different, but these kind of structure nearby also we can see. And if you go to any states or any other uh, nearby states also, there is these kind of structures will be there. In some regions, it may be called as talab. It is a reservoir kind of a thing, and in some particular place, it is a johad, that is community pond. Some community based temple will be there. There will be some ponds will be there. So that is used to be one of the conservative method. We can call it as in Kalyani and all. So step wells. So that is in Gujarat and all. There may be a Jalra they call, and some earthen bunds here also in vented dams. The farmers used to construct the vented dams, that is urban bunds, to stop the water during the rainy season when there is a off rain. So this water can be used for agriculture purpose or for a drinking purpose. Then flood water harvesting. So excess water we can harvest and we can save it for the non-rainy seasons. We can learn from our ancestors how beautifully they have constructed these particular structures for water storage. So from the in the lowest region of the city, they used to identify the place for water harvesting, and the conveyance system, how the water is conveyed from all the along the way to the city to these particular places, and conserving in a holistic way. So this particular example, the Adalaj Ki Bavdi. So this is in Ahmedabad of Gujarat. It is a step well and five-storied of octagonal in shape. So it is an unique example of architecture having a 16 pillars, and the sunlight falls on a water is very short time. So that's why inside this particular structure it's always cool. And they used to wiggle this water. So that's, I know they have given a holistic approach for conserving this water. And these are all some of the other practices, water conservations in nearby our, if you see in Karnataka or in some other state, nearby state also, the practice is same. Like if you take any forts earlier, where the kingdoms used to be there. So how they used to convey the water so from the catchment area to a particular pond, and that they used to filter using a traditional techniques, and they used to reuse it and with a minimum wastages. So that is what these are all the some of the examples. Some in there is in Melkote of Mysore, so some it is in Chitradurga and nearby places. So some water will be there. The construction for conserving water, then taking it to in a wells and distributing it back to the particular this. And rainwater harvesting is the best way of storing the water. And if you harvest the rainwater, then it reduces the burden for pumping the water from source to the end user. Also, resource management will be well maintained. So, what are all the components of rainwater harvesting? If you ask, it is a catchment area. Our rooftop is a catchment. So, from the rooftop or a pavement, from or the some particular uh, what is that ground and all, we can collect the water in the downstream side, and through gutters or pipes or some channels we can carry that water and store it, and use some basic screening materials, sand, coarse aggregate, fine aggregate, and the charcoal, and you can filter and you can use it. If you properly filter it, you can also use it for drinking purpose, and very well it is used for irrigation and at least for a toilet flushing without filtering. So this will reduce us the burden of pumping the water from source to the consumer. So then water conservation reduces the dependency on groundwater, also the municipal water. We should not rely on only a single source. So that will give us during March season, municipal water supply will be very less, and the quality of the water will also deteriorate because of many reasons and all. And it also saves the cost. So with the minimum construction, it will go for a long life. It will save so much of water bills, and also it acts like an alternative source of water, and it will prevent the flooding. So what happens once you store everybody, if you harvest the rainwater, so the water availability for the runoff will be reduced. So it reduces the flooding, thereby soil erosion, these kind of problem will be reduced. So that will be the added advantage. Silt deposit and rising of the say sea level, or whenever we construct a bund due to silt deposit, the water storing capacity will be less. See, all these things will be the indirect benefit of rainwater harvesting. The groundwater recharge will be taking place, and we can use it for the cleaner water. That is, without any pollution, we can harvest this water and we can use it. So this will be one of the sustainable, renewable source of water. So types of rainwater harvesting may be anything, smaller to bigger. It's not a problem. So here the some best practices we can see. So some of them constructed well. So say obviously well should be perforated so that the nearby water will infiltrate or percolate through this particular kind of a structure. So if you're using these rings and all, make sure there should be some perforation or some holes provision for entering of the groundwater. So beside that, you can make this particular kind of a coarse aggregate provisions, or you can use your used wall tiles that can be poured next to the particular piping, so that what happens, it will act like a gallery. So where the rainwater will be harvested and filtered, and it will be into the well. So your at least you will be contributing to the groundwater recharge. So it may not contribute for your own purpose, but at least it will recharge nearby wells or nearby groundwater table. So some if it is a tube well, you can construct these kind of structures surrounding some radius or rectangle or any in a geometric shape, no problem. So you can harvest the water, and you can use some this coarse aggregate, fine aggregate, sand, charcoal combination in a layers, so that the infiltrated water should not have any impurities. So that is why you can recharge your tube wells, the open wells, if not yours, but it will contribute for the groundwater table increase. So somehow it will be contributing to a particular groundwater recharge. So in particular Mumbai, a resident, he made a simple arrangement. He has taken a particular a storage tank, and from the rooftop, whatever the rooftop water, he is harvesting in this particular drum shape. So he made a perforations in the drum. You can see the perforations here. So the rainwater, rooftop water will be made enter into this particular drum. So here there will be some coarse aggregate, fine aggregate, charcoal, sand layers will be there. So once the rainwater enters in this particular drum, so after filtering, it will get into the particular soil. So by means of that, it will recharge the groundwater. So another example, so usually in rural areas, you can see these kind of structures. There will be a pond. So the down in a rural, the downstream areas they will select, and they will construct some bund, and they will store the water. Inside the pond, there will be some open well. So in that open well, what happens? through the soil will act like a infiltration media or a filtering media. So the filtered water will be get inside the open well. So from the open well, that water can be pumped for the daily utility usages. And nowadays you can see this is a one particular filtering media that is readily available. So from the rooftop, this particular filtering media we can buy in a local vendor, and first water, harvested water should not be allowed to the directly to the borewell or open well. So later, after some 1 or 2 harvest, what happens? The rooftop will be clean. So after that, you can close this outlet wall and you can directly get into put into this particular tube well or a open well. So and there is nothing like this is the only way of harvesting. In a simple way, also we can harvest using our locally available material or some whatever the broken tanks or whatever the facility we have. The using that, at least we can some portion we can contribute for the groundwater recharge. So that will be the great help for our mother nature. So you can see this is a very small particular bund they have constructed, and this will be sufficient for 1 or 2 month like agriculture purpose or for animal drinking water, all those things. And you can see the contour type of cultivation. So it should be like in a particular slopy ground, we can make a contour shape of shapes so that water will be stored in this contour. After filling the topmost contour, it will reach to the next, it will reach to the next. So by then we can reduce the soil erosion also, as well as it will contribute for the groundwater recharge. So these are all the like agricultural ponds. So where farmer they can own their own plot, so that they can use the downstream area, or some marshy land will be there, or some unused land will be there, that they can convert it into agricultural pond. There is a subsidy available from the government also. Government is also supporting, so they can store the water, and at least it will be used for the in a drought condition. So you can see in the olden days also, this is bamboo is made for the conduit. Like if pipe cost is more, then if locally available bamboo is available, that can be converted as a the pipe media, so water can be conveyed from one place to another place. And if the particular area is having a rocky outcrop, so small portion of the rocky outcrop can be drilled, so then the provision for a water flowing can be done. So these kind of stepped ponds are always good for storing of water. So it will contribute to the recharge. It will reduce the runoff, and it will use for the non-rainy season for agriculture purpose. Farmers are practicing. They use some sandbags or some locally available materials, some poles, logs for conserving the water. So this is a very good example for a contour kind of a harvesting. So usually for growing paddy and all, they cultivate and store the water. So that will also helps for the groundwater recharge and also the soil erosion. So so this is a typical example of a rainwater harvesting. So some mesh they have provided for the particular filtering. So once the channels are there, that will carry the runoff. So that for particular channel, so we are providing some coarse aggregate, then some fine aggregate, then some charcoal. If you provide that, water will be filtered. So for the debris like a leaf, logs and all, so that can be um, put in a pond, so that the water and you should make the velocity should be less, so that the recharge will be more. uh, and this is a particular component. So whenever we go for rainwater harvesting, there should be catchment. So it may be rooftop or any small area. There are some conveyance system, pipes, then one storage media. Before storage media, if it is there is a filtering provision, that will be very good. Then for distributing. So whatever the collected water, that can be distributed for the daily utility purpose. So in older days also they have practiced this particular. So if you visit any fort and all, the water management is very well. So you can yeah, this particular example I can take Sinhagad Fort. Um, so they have a very good particular water conservation plan. So in the catchment, topmost catchment, they have a wall provisions. So where the all the rainwater will be diverted towards a particular pond. So in a pond, it will filter and it will enter to another pond. The after the filtered water, they will use it for drinking water purpose and daily utility purpose. So this was the best practice which they have adopted in those days. Even when the enemy used to attack their fort and all, so they used to plan. We want to stop their particular drinking water, and they should not have a food provision. But these kingdoms were maintaining this particular water for agriculture purpose also, for drinking purpose also, so that without moving out from the fort, they can survive at least 5 years. So that was the plan they used to make. So this is also traditional water harvesting structures in Rajasthan. We can see these kind of stepped wells. So then I was talking about the best practice should be in all the ways. So when coming to the harvesting, we need to harvest the water. That is the source of a water, the precipitation. Then how to save the water. The next portion is maximum utility is irrigation. So that is also because India is a agricultural dependent area. Say 70 percentage are farmers are dependent on this particular irrigation and all. So what type of irrigation is suitable? So drip irrigation is the best one because of its efficiency. You can irrigate during non-shining hours. Like in a daytime, you no need to provide the water because it may lose in the form of evaporation. So that's why you can utilize this particular water. Uh, like you can irrigate the water in during night, so that in the daytime the evaporation will be less, and what the cooling effect will be there, and whatever the amount of water and required for the crop will it will self sufficient. So then you saw for some crop it is not feasible. Say for example for annual crops and all we can't provide the drip irrigation. So we have max to max where and all for a plantation crop and all drip irrigation is at most useful. And in some annual crops, if drip irrigation is not feasible, go for a sprinkler irrigation. In drip irrigation, what happens? We can control the weed and we can supply the whatever the fertilizer. Nowadays, fertilizer also available in the liquid form. And there was a study. So rather than providing fertilizer in a once in a 3 months or a 6 month, they are providing with the less dose in a daily basis. They got the better yield. There are scientifically proven studies. So why can't we adapt these kind of a techniques so we can grow the much more yield also we will get, and cost also reduced, and weed control is also there, and also particular water is also saved. So then if not at all possible, drip irrigation is not at all possible, go for sprinkler irrigation. That too in night time you can irrigate the crop, and daytime you can stop because of the sunshine hours, the water evaporation losses we can prevent. So like that we can uh, some modification. So if surface irrigation is there, go for sprinklers. If sprinkler is there, go for drip. And subsurface infiltration. Some buried pipes will be there. So there will be perforated pipes. If you use the subsurface irrigation, that is very much uh, efficient irrigation system. So then, so how the water can be recycled? So in recycle, it depends upon scale. So in a domestic also we can recycle. How? If you ask, let's say if you have a particular wash basin, so whatever the water used in a wash basin, so there itself you can divert it for your gardening purpose. So that is not having any sullage or sewage water. So no problem. So and some particular wash basin can be connected to the flush tanks, so that water can be stored. The whatever the used water you can store in the flush tanks. Then flush tank water can be used for flushing purpose, so that at least 20-50 liters of water is saved. So like this, so the scale may be small, but the effect is more. At least in a house, within a house, if you are saving 500 liters of water, it's a great achievement. So then, in a large scale, say industry and particular domestic, all the sewage water, sewage water, all those things water can be recycled. See nowadays in Singapore, they are utilizing all the particular recycled water only. And in India and in our Bangalore also we have sewage treatment plants. So efficiently we are using the particular the water, used water into the particular usable water. So then in an individual manner, like if you can adapt, if you have some motivation towards our mother earth, so instead of putting particular flood irrigation system, we can go for drip irrigation and mulching around the plant, so that the evaporation we can control. Rather than taking a long showers, we can cut it off particular 5 minutes or less. Then particular flush tanks we can reduce. So some filled bottle, if you put it in your flush tanks, so one another you can save 2 liters of water. So if the flushing is kept for 20 liter, you can reduce it to 15 liter. So some slight modification you can have. And in some flush tanks there is a maximum water, minimum water control is also provided. So you can encourage to buy those kind of, and you can adopt so that fine. And energy saving washing machines, and use the nozzle guns instead of the ordinary piping of water. And faucets will be having some aerators. The aerators will reduce the amount of water in a drastic manner. And whenever the taps are not in use, please turn off. And so whenever brooming is possible, rather than jet wash, to go for brooming. So these are all in a personal level. And leakage taps can be monitored, maintained, and whenever possible, so washing. So please, you can, in a personal level, we can adopt these kind of techniques, so to save the water. So then technology based. So Isam, I think my slides are visible and I am audible.
Yes, sir. Yes, sir.
Okay, thank you. So then there is a innovative solution. So what technology can be used for saving the waters? So nowadays we are everything is smart. So why can't in irrigation also in a smarter way? You can use soil moisture sensor, and you can use the automatic watering system. It is possible. So in other countries and all, they have already adopted. So they use all the weather parameters, and using that weather parameter as an input, and soil moisture sensors they are using for measuring the soil moisture. That is also given for the input for the Internet of Things. So then it will logic some crop water requirement also we can identify crop demand, all those things we can we have that studies, how much crop required, what amount of irrigation, everything is there is a uh, study. So using that techniques, we can optimize the irrigation. So optimizing irrigation will give you the better yield. So better particular efficiency we can achieve. So these kind of techniques. So it may be in a small scale or it may be in a large scale. These kind of techniques are useful. So then other techniques, say desalination, because 75 percentage of the water is available in ocean. So you can desalinate the water and you can use it. But it is a costliest procedure compared to the naturally available the water. So you need energy for heating and evaporated water you need to collect, but the whatever the fresh water collected from the precipitation is having the minerals that may not be available in this particular processed water. So what Mother Earth is given, it is having all the minerals and all the required particular supplements in that water for the human body. So if you treat these waters, some deficiency may be there. That is why the first preference should be for our the gifted one. That is a precipitation water we need to utilize. So some techniques like wherever there is a water bodies. So water bodies can be used for solar panels investment, like for electricity production. So it will serve two purpose. The land use, so because land is having a high value, so simply if you install the solar panels in the land utility will be then the scarcity will be there. But if you install solar panels on the water body, there are two advantages. So one is the evaporation you can control, so that saves the maximum amount of water, and the area is also utilized. And these particular solar panels, in the bottom portion, it is so much of heat energy is produced that will dissipated by this water body. So by these integrating techniques, we can achieve the maximum benefits. So then some of the nanotechnology water treatment nowadays they are upcoming. So you can use nano materials for um, desalination or particular bacteria. All those purpose we can to treat the wastewater. We can use latest technologies. So then, so we can, so nowadays everything is of data. So why can't we collect the data from a reservoir, from the sensor? So we can monitor like if the particular house is utilizing a particular amount of water, suddenly if it is increased or decreased, so there is a information. So something may be damaged or some leakage will be there. So water meters. So adopting these techniques like sensors, all those things, we can identify the leakages. So we can prevent the leakages, so save the water, and what is the required amount of water. So that will be automatically driven by the source. So these things are very much essential nowadays. Yeah, these technologies are adopted. So it will reduce the burden on wastewater treatment. Simply without using the water, the leakage, the water will be entered into the sewage treatment plants. That will be again burden. That water need to be pumped and the coagulation process, all the sedimentation, settlement tanks. So it will create a huge whatever the load on water treatment plants. So these kind of techniques are very much essential. Smart water and wastewater treatment and management. So this is very much essential nowadays. So then, what are all the nature based? So nature is already uh, giving some solutions to preserve or save the water. So we have wetlands. The wetland ecosystem is a very beautiful thing. So for a human being, it provides an aesthetic service and a recreational opportunities. Unfortunately, we are losing so many wetlands nearby. So it is an ecosystem. So where small ecosystem will be there, a fishing zone and a new type of a uh, breeding of a fish. All those things it gives some ecosystem that is nowadays. We have a threat for this particular ecosystem also. So we have to identify this ecosystem and they have to preserve. So what happens? This will be storing the water and slowly it will reach as the groundwater and whatever the settled water which will be free from all the debris and all. So later it will join the stream. So it serves the purpose of groundwater recharge also, ecosystem also, and water purifying agent. And there are some nature-based solution which is already available. The best example, mangrove forest, we can call it as. So mangroves, earlier we used to see a lot of mangroves, but now they are removed and they are constructing a breakwater. But these mangroves will dissipate the energy from the tides, so that whatever the coastal mm, region is protected naturally, and also there is a ecosystem in this particular mangrove forest, so that should be there rather than providing a human based like a breakwater, man-made breakwaters, all those things. We should encourage nature-based solution, so that it will serve both the purpose, so we can have the ecosystem and the recharge, and also some estuary view and all the recreation center that will be um, there. And these kind of structures, so nowadays in Mangalore, if you see everywhere there is a pavement. So once the high rise building comes, they will also put all the interlocks, and when once the road is provided, all the roads without any drainage, there will be rigid payments or flexible payments, and rooftop also they are covering with the GI sheets. So where water has to percolate, there is no provision for percolating the water at all. So that will enter to the downmost portion, and if some blockage in drainage is there, then entire water will be like a flood. So that's why in wherever possible in the roads, so these kind of provisions should be provided. Whatever the water runoff from the pavements, that should be collected in the particular provisions like uh, soil, permeable soils, and some infiltration medias. So by means of which we can convey this water to the required desired ponds, or somewhere it can be carried. So that should be the best practices. So rather than converting entire area into the paved one, so these kind of practices is the best one. Sometimes the percolated uh, pavements, and say in a particular interlocking system, we should have some infiltration capacity. So like that, a small changes or a small adoption, so leads maximum contribution to the mother earth. So and cities, all the cities, you should avoid all the city, entire city as a pavement only, or a rigid, or a man-made thing. So some provision for gardening, some for provision for infiltration galleries, some recharge pit, some rainwater harvesting units, are very much essential. So this should be the essential part. And if you are uh, cultivating some crops, mulching. So mulching means covering the plant, the soil portion other than the plant. So with some cover, it may be rice husk or a straw or a polythene paper or particular coconut coils. Anything may be okay, but it acts like a uh, the cocoa pit, like it acts like a both fertilizer, as well as it seizes the evaporation, so loss of water. That is very much essential. These practices will be best practice for conserving waters. So, and if you some industry, they have some giving back to society policy, they can whatever the used water can be uh, filtered, and all the after all the particular purifying techniques, that water can be re-injected to the groundwater. So it will contribute to the groundwater recharge, and it will create a source of drinking water, and groundwater recharge. So that's how individual also in a house, in a domestic uh, particular small scale also we can do that. So we can recharge particular groundwater by means of small uh, in a tube well surrounding 1 meter, or either at least 3 feet area, we can use as a gallery to recharge the groundwater. So then what a community based techniques can be adopted for a particular nature for conserving the water. So there are some communities, they have built their own ponds for their villages. There are so many examples. They only initiated and they wanted some water, so that's why they only created some bund, some pond, desiltation, all those things. And there was a Narega Yojana, like so for Kuligagi Kal Yojana. So in that desiltation process was there, so that the catchment holds more volume of water than before, and also it will contribute for the recharge and fishiculture, and it can be used for agriculture and also for animals, so drinking water. So this serves as a particular source of water. And educating school level itself, educating what is the importance of water, why we need to conserve. Because nowadays we can see that there is a don't care attitude. If there is a some tap is open, so we can see some of the videos where animal will close the tap, but a human being is not interested to close the tap. So if the water is leaking, so nobody bothers, he will just simply run out of cloth. But that is at most important. We need to take some action. So where there is a leakage, we need to inform to the authority, so that they will repair it, so that you can save enormous amount of water wastage. At least if you controlling the waste, that is at most important. Or else one day we don't have water. Now only we are paying 20 liters per liter, so in future it may goes up, so that will be for sure. So ancient techniques like in Meghalaya or some other Nagpur and all, they used to have this bamboo as a conduits to carry the water from hilly areas to their farm land and agriculture. So this use it this they were using as a drip irrigation system. Then, so where and all the water management can be possible. So in agriculture sector, the irrigation practices. In construction sector, simply they keep opening the tap and simply doing other works. So these things we have to control, because getting water from the tankers and wasting uh, may not be feasible for the construction activity. And in residential buildings, so what are all the conservation techniques we have? Recreational industries, how the water is managed, recycled, all those things. And in manufacturing industries, where water is used as a coolant, so how the water is managed. It should be economical and in a sustainable way of management, so that the best utilization will be done. So these things we already discussed. So if possible, advanced technology we need to adopt. There may be we uh, talk about AI, artificial intelligence. In this area also it is required. Artificial intelligence when we need a water. So when there is a presence of a person, then only tap should go on. Then automatically it should off. Then some quantity should be maintained. So that much quantity it has to discharge. All these things we can develop and can adopt for a day-to-day life. So if you see, if you are like, what are all the best practices? When we see the neighboring countries, so what they are doing? So reuse, recycle, and from that particular they are achieving more. So that is the technique. So they are whatever the available sources, the waste water they are utilizing for the irrigation purpose. So that serves the both two problems is solved in a one particular uh, technology adoption. And the water loop, say water is not it is uh, neither be created. So that is the problem. You can't create the water from H2O. So, but we are using two hydrogen and one oxygen. We can't create the water. So we need to utilize whatever the available water. The storm water management is best practice, and whatever the waste water that need to be treated well and utilized. So desalination, so the wherever necessary. So because with a growing population, the demand also increases. Industrialization will happen. So they also need water. So that is why. So we need to adapt and we need to conserve the water at any cost. So the green infrastructure flood management. So this is most essential. Nowhere we can see these kind of structures. So where some coarse aggregate or pebbles are put so that the water is filtered through these permeable pavements and it will reach at the ground, or from this particular uh, channels we can draw the water to the ponds and all. So these things are very much essential. Nowadays we are telling the smart cities, but these provisions are not available. So we need to look into it. So ultimately we can conclude, so with the water in a particular person based, or it may be technology based, or it may be nature based, or in a community driven, any way the conservation we need to adopt. So either the integration of traditional modern is also fine, or sustainable management is required, and awareness is very much essential, because every drop counts. Act today to save water for tomorrow. So that is what in a sustainable development goal. So whatever the United Nations uh, goal, so they have kept 17 goals. So in that, everyone has access to clean water and sanitization. So this particular sustainable development is a model of development that meets the needs of the present without compromising the ability of future generation to meet their own needs. So uh, it was there in ancient period only. It was there. Now they are calling it as SDG 6, but it was already there in our ancient ancestors. They are already followed. So I will end up with my talk with a few heroes. Like I can call them as an heroes. So this particular slogan, wherever rivers Ganga, Yamuna, Godavari, Saraswati, Narmada, Sindhu, and Kaveri, please be present in this water. We used to chant. So our ancestors are given holiest approach for this particular water, and few heroes. They have understood the water value of a water. Then this person Simon Warren bought the water from a forest and all, so many kilometers he has made a channels and filled it to the pond, and the barren land he converted as an agricultural land. When there was a drought, they were not at all getting any crop. After his contribution, now they are getting 3 crops per a year. So that is why government recognized him and awarded Padma Shri. Then our own Dakshin Kannada person, he is known as a tunnel man. So he digged the water from a tunnel and converted barren land into the lush green farm. So he also awarded with the Padma Shri award. So and 84 years, the shipyard from Karnataka, he created 14 ponds for animal drinking purpose. The his name is Kemagowda. So there are many civil engineers, traditional engineers I can call. There are unnoticed engineers. In our community only, there are many unnoticed engineers who will conserve the water. He will, at least it will be utilized for any purpose, drinking water, or for a agriculture purpose, or for aquaculture. So there are real engineers. And recently we lost our one Diamond Tulsi Gowda, so who planted 30,000 plus saplings. So who is literate now? I don't know. So who is literate? So those who are unnoticing the open tap are the real heroes, or these people are the real heroes? The decision is left to you. So think and act. That's all. Thank you.